Good morning, guys. In this video, we are going to cover log. It's a very interesting topic. It's a very interesting chapter. We're going to cover log basics. Okay, we're going to cover in this video what is log, what are its limitations, how can we, what tells us that this is a proper logarithmic function, and we'll take a few questions. Okay, now we are all very familiar with exponents. We know that this 2 raised to 4 is equal to 16. We know that this is an exponent. This is an exponential function. Okay. So we can generalize that a raised to x is equal to n. Any number can be represented in an exponential relation. Okay. This same relation can also be expressed in one more way, that is log. Okay. 2 raised to 4 is equal to 16. Now in this exponential function, this is called argument. This is the exponent. And this is called the base. Okay. Now, when you convert this same thing into the logarithmic function, the argument, first we write log, then we write the argument, and then down the base, and the answer is the exponent. Okay, this is read as log of 16 to the base 2 is equal to 4. Okay, right. Now let's look at some limitations of log. What defines log? First one, let's take this log of n to the base a. Okay, how can what tells us that this is a proper logarithmic function? Okay, that's what we're going to discuss over here. The first thing, n, that is the argument in exponential form, has to be greater than 0. Okay. Second, the a, that is the base in the exponential form, has to be greater than 0. And lastly, a can never be equal to 1. Okay. Let's take a few notes from this. For any given value of n, log of n to the base a has unique value. It always has a unique value. Log of 0 does not exist. Now we might be asking, why does log of 0 does not exist? We can represent anything in log. We can represent a number in logarithmic function. Why can't we represent 0? Let's take an example for this. Log of 0 to the base 2. Okay. Now when we convert this into the exponential form, we know that this 0 will become the argument and 2 will become the base. Let's take x as the exponent. Now, what raised to 2 will give us 0? We don't know the answer. What raised to 2 will give us a 0? We don't know, because the x is not defined. X is not there. We cannot represent 0 in exponential form either. That is the reason, that's the main reason we can't represent log of 0. Okay. Now, log of negative number does not exist. Does not exist. Okay. Fine. Now let's take a few questions. First question. Question number 1. Log m to the base 4 is equal to 1.5. Let's convert this first into the exponential form. M is equal to 4 raised to 1.5. This 1.5 can be written like this: 15 by 10, which is equal to 3 by 2. Therefore, m is equal to 4 raised to 3 by 2. Now 4 can be written as 2 square, 3 by 2. We know that this will become 2 into 3 by 2. Therefore, m, 2 gets cancelled, and 2 cube, which is equal to 8. 8 is the answer. Okay, let's take the next question. Question 2. Log 27 to the base root 3. What's the answer? Let's first convert this into the exponential form. 27 is equal to root 3 raised to x. Now we know that 27 can be represented root 3 raised to 6, which is equal to root 3 raised to x. From this it's clear that x is equal to 6. 6 is equal to x. Okay, fine. Next question. Question number 3. Log 2 root 2 to the base 2. For solving this, let's again convert first. Let's convert this first into the exponential form. Okay, 2 root 2, which will become the argument in exponential form, is equal to 2, which is the base, raised to x. Now let's split this 2 root 2, 2 raised to 1 into root 2 is equal to 2 raised to x. Now this root 2 can be represented as 2 raised to 1 by 2, which is equal to 2 raised to x. Now with the help of exponents rule, we know that 2 1 plus 1 by 2 is equal to 2 raised to x. Let's take the LCM. It will become 3 by 2 is equal to 2 raised to x. From this, x is clearly 3 by 2. Nice. Okay. I hope the basics of logarithm is clear to you. More videos on logarithm and other interesting and fun concepts are on the way. Stay tuned to BrainlyKidz.